Let's talk about roots. And the first question, what is a root? What exactly is a root? A square root, a cubed root, what is a root? Well, let me write an example here. Suppose I wrote x squared equals 4. X itself could be either positive 2 or it could be negative 2. Positive 2 times 2, of course, is positive 4. But negative 2 times negative 2 is also a positive 4. So x has two roots, in this case, square roots. Now, one thing to keep in mind, suppose I wrote the number 4 underneath a square root sign, a square root symbol. But by definition, it's only the positive root. So if you see the square root symbol, the result is just the positive number, the positive root. In theory, if I wanted to write something like that, plus minus root 4, okay, well in that case you have positive 2, negative 2. How about cubed roots? Suppose I had x raised to the power of 3x cubed equals 27, then x itself is 3 and only 3. And if I were to write cubed root of 27, it's only 3. So if the exponent is an even number, you get two roots, one positive, one negative. But if the exponent is an odd number, you only have one root. Another example, suppose x cubed equals negative 27. Well, in that case, x itself is negative 3. The cubed root of negative 27 is negative 3. And I'm going to write a little 3 in that divot. That means cubed root, right? The cubed root of negative 27 is negative 3. Negative 3 times negative 3 is positive 9, times negative 3 again is negative 27. Suppose I wrote x to the power of 4, x to the fourth equals 81. Well, in that case, x itself is equal to 3. Since the exponent is an even number, there's only one root and it's a positive root, positive 3. How would I express this with a symbol? I would write a 4 in this little divot here. The fourth root of 81 is equal to 3. So going back to the question we started with, what exactly is a root? What's a fourth root? It's a number that when multiplied by itself 4 times brings you back to the number you started with. A cubed root is a number that when you multiply it by itself 3 times brings you back to the number you started with, A square root, a number that when you multiply it by itself twice brings you back to the number you started with. So that's what roots are all about. Let's talk about the relationship between roots and powers, roots and exponents. So I've written a few examples here of exponents. Of course, 4 to the 1 is just 4 itself. 4 squared, we know what that is. That's 4 times 4, it's 16. 4 to the 0, anything to the 0 is 1, except 0 to the 0. That's undefined, but that's not important. And negative exponents, what's 4 to the negative 1? Well, it's 1 over 4 to the positive 1. It's 1 over 4 to the positive 1. It's just 1 over 4. Okay, all well and good. How about roots? A root is a fractional exponent. So if I wrote here 4 to the 1/2 or 4 to the 1/3, 4 to the 1/2 is simply the square root of 4. And square root, by the way, there's an implied 2 inside that little divot. I'll erase that. Cubed root, 4 to the 1/3 is the cubed root of 4. That's what a root is. It's a fractional exponent. And this all makes sense. The square root of 4 is 2. Why is that? Well, the square root of 4 is the same thing as the square root of 2 squared. It's 2 squared raised to the power of 1/2. 2 times 1/2 is 1. It's 2 to the 1. It's just 2. How about the cubed root of 4? Well, the cubed root of 4, it's not a whole number. It's 1.6 something off into infinity. So a root isn't always a whole number. If that's the case, the root is called an irrational number, which means what? The decimal places go off into infinity. So let's see another example. Suppose I wrote the number 5 raised to the power of 1/2. That's the same thing as the square root of 5, which is equal to 2.236 something. It goes off into infinity. So that's an irrational number. The number of decimal spaces, it goes off into infinity. And we can round this too. So I could say the square root of 5 is approximately equal to 2.2. On that subject, there are a few square roots that are really worth memorizing that are irrational numbers. The square root of 2 is, 1.414 off into infinity. But you just want to round that to, it's about 1.4. So you want to memorize the square root of 2. It's about 1.4. I'm going to write approximately equal to. How about the square root of 3? That is approximately 1.7, so you want to memorize that. And then the square root of 5, that's worth memorizing. We said that's approximately equal to 2.2. So those are good square roots that are irrational numbers that you want to round up and memorize. So the relationship between roots and powers, between roots and exponents, I've written some out here. The square root of 4 is, of course, 2. It is 4 to the 1/2. It is 2 squared to the 1/2. It is 2 to the 1. It is 2. 2 raised to the power of 1 is 2. How about the cubed root of 27? That we said is 3. Cubed root of 27 is 27 raised to the power of 1/3. It is 3 cubed. It is 3 times 3 times 3. It is 3 cubed raised to the power of 1/3. It is simply 3. Cubed root of 27 is 3. The fourth root of 16 happens to be 2. It is 16 raised to the power of 1/4. 16 is 2 to the 4th. 2 times itself 4 times is 16. So 2 to the 4th to the 1/4. 2 to the 1. The fourth root of 16 is simply 2. Square root, there's an implied 2 in here. But when you write the square root symbol, it's just sort of understood that you don't need to write the 2 if it's just a square root. But for other roots, you do need to write the number in there. And that's called the index. Cubed root 3 is the index number. Fourth root 4 is the index number. A little more on cubed roots. The cubed root of 8 is, well, it's the cubed root of 8 is 2 times 2 times 2. And I got to write the 3 in here. It is the cubed root of 2 cubed. The cubed root and the cubing cancel each other, so it is simply 2. You see a 2 appear 3 times, you pull it out once. The cubed root of -8, that is the cubed root of -2 times -2 times -2. So -2 times itself 3 times. That's the same thing as the cubed root of -2 cubed. And here again, the cubing and the cubed root cancel each other, so it'll be -2. Now, a point on square roots, you can have the cubed root of a negative number. You cannot have the square root of a negative number. So square root of -4 does not exist, not defined. There's no number that you can multiply by itself twice to get a negative number. So no such thing as the square root of a negative number. Let's talk a little bit about simplifying roots. What does that mean? Suppose I wrote the square root of 8. Well, there's a different way I could write that. I could ask myself, does 8 have any factors, any divisors? Is it divisible by anything that is itself a perfect square? Yes, 8 is 4 times 2. 4 times 2, 4 is a perfect square. So the square root of 8 is the same thing as the square root of 4 times 2. Well, you can separate those. That is the same thing as the square root of 4 times the square root of 2. That is the same thing as 2 times the square root of 2, 2 root 2. So you can simplify a root in that way by asking, is it divisible by any number that is itself a perfect square? How about the square root of 18? Well, 18 is 9 times 2. 9 is a perfect square, so it's the same thing as the square root of 9 times 2. It's the same thing as the square root of 9 times the square root of 2. It's the same thing as 3 root 2. How about cubed roots? How about the cubed root of 24? Well, you asked, does 24 have any factors? Is it divisible by anything that is itself a perfect cube? And the answer is yes. 24 is divisible by 8. 8 is a perfect cube. 24 is 8 times 3. So the cubed root of 24 is the same thing as the cubed root of 8 times 3. Well, that's the same as what? The cubed root of 8 times the cubed root of 3. Cubed root of 8 is 2. Cubed root of 3 is the cubed root of 3. So cubed root of 24 can be rewritten as 2 times the cubed root of 3. And one last example here. Let me do a little erasing. How about the cubed root of -16? Well, is 16 divisible by any number that is a perfect cube? Yes, 16 is also divisible by 8. 8 is a perfect cube. So the cubed root of -16, same thing as the cubed root of -8 times 2. -8 times 2. Cubed root of -8 times the cubed root of +2, cubed root of +2. So that's what? -2 times the cubed root of 2. A final point I want to make here, suppose somebody asked you the square root of 18. That's what? That's approximately what? Well, to get a ballpark figure, you could ask, what is the square root of 16? And what is the square root of 25? A perfect square that is greater than 18. Square root of 16 is 4. Square root of 25 is 5. So I know that the square root of 18 is somewhere in between 4 and 5. So a little estimating can be very helpful sometimes. Let's talk about the number 10 raised to an exponent and the roots of 10 when it's raised to an exponent. Square root of 100, same thing as the square root of 10 squared. Square root of 1,000 is the same thing as the square root of 10 cubed, and then 10,000 is 10 to the 4th. Well, square root of 10 squared, that is the same thing as 10 squared to the power of 1/2, which is 10 to the 1. It's simply 10. So the moral of the story, if the exponent is 2, you divide by 2. You take 1/2 of that, it's 10 to the 1. Suppose I look at the square root of 10 to the 4th, and this looks like I've written 104, so let me change that just a little bit. This is square root of 10 raised to the power of 4, 10 to the 4th. Square root of 10 to the 4th is the same thing as 10 to the 4th raised to the power 1/2. Raised to the 1/2 means square root. Well, that is the same thing as 10 squared. So what do? You take the exponent and you simply divide by 2. So the square root of 10 to the 4th is 10 squared, just as the square root of 10 squared is what? 10 to the 1. Now, that's all well and good, but how about the square root of 10 cubed? Well, if I write this as 10 cubed raised to the power of 1/2, I have what? I have 10 to the 3/2, but that's kind of ugly. That doesn't seem to be very helpful. There's another way you want to write it. The square root of 10 cubed, that's the same thing as the square root of 10 squared times the square root of 10, which is what? The square root of 10 squared is simply 10. So 10 root 10, 10 times the square root of 10. So if you have the square root of 10 raised to an odd power, an odd exponent, you can simply rewrite this as square root of 10 raised to an even exponent, in this case 2, times the square root of 10, and you can rewrite it that way. And that's true of 10 raised to an odd power. It's true of anything raised to an odd power, any positive number raised to an odd power. If I saw the square root of 2 cubed, I could rewrite that as, well, that's the same thing as the square root of 2 squared times the square root of 2. That is what? That is simply 2 times the square root of 2. That is 2 root 2. So something to be aware of if you see the square root of a number raised to an exponent that is odd, a power that is odd. Let's talk about the square roots of fractions. Here I've written out a fraction raised to different exponents, and you see that if it's a fraction raised to a positive exponent, the number gets smaller, not bigger. And so you can see the way I've written this. If you reduce the exponent, if you make the exponent a smaller number, the fraction, when raised to an exponent, gets bigger, not smaller. So I wrote the square root of 1/4 to the 1 is simply 1/4. How about this? And the square root of 1/4 to the 0 is 1. Suppose I write 1/4 to the 1/2. Suppose I write square root of 1/4. Well, it's a number that is in between 1/4 and 1. And what is it? It's 1/2. The square root of 1/4 is 1/2. If I were to write the number line, this is a really important thing to remember. If I were to write the number line and I put 1/4 in here, so the square root of 1/4, it's not a smaller number, it's a bigger number. The square root of 1/4, the square root of 1/4 is 1/2. So if you take the square root of a fraction, the number gets bigger, not smaller. And when I say bigger, that means what? That means you move to the right on the number line. As you move to the right on a number line, the number gets bigger, not smaller. Now let's talk about the cubed root of fractions. Suppose I write 1/8. The cubed root of 1/8, the cubed root of 1/8, it is a bigger number, not a smaller number. It is 1/2. 1/2 cubed is 1/8, so the cubed root of 1/8 is 1/2. You're moving to the right on the number line. Now, how about the cubed root of negative 1/8? Well, that is negative 1/2, so you're actually moving to the left on the number line if you're taking the cubed root of a negative fraction. Negative 1/2 is the cubed root of negative 1/8. you're moving to the left on the number line, you're getting smaller. Let's talk about imaginary numbers. If I were to write I, you'll see the letter I equals the square root of -1. Well, negative numbers don't have square roots. It's an imaginary number. So let's look at this a little bit. Suppose you were asked what is the square root of negative 25. How could you rewrite that? Well, that's the same thing as the square root of positive 25 times the square root of -1, which is what? 5 times the square root of -1, which is 5 times I. The square root of -1 is I. Suppose I saw I squared. That's what? That's the same as the square root of -1 times the square root of -1. That is, I squared is the same thing as simply -1, okay? So if you asked me what is 5i times 2i, well, 5 times 2 is 10, and I times I squared is -1, so 5i times 2i is equal to -10. Suppose you saw 3i squared. Well, that means you square the 3, and you also square the I. So 3 squared is 9. I squared, we said I squared is -1. So 3i squared is -9. Let's talk about some rules, some laws to memorize with regard to roots. So if I had square root of x times square root of y, that is equal to the square root of x times y. If you're multiplying the numbers, you can put them underneath the same square root sign and multiply them underneath the same square root sign. So if you asked me what is the square root of 4 times the square root of 9, that's the same thing as the square root of 4 times 9. And 9 times 4 is 36. So that's the same thing as the square root of 36. And that makes sense. Square root of 4 is 2. Square root of 9 is 3. 2 times 3 equals 6. And yes, the square root of 36 is 6. So that's an important rule to memorize. Now, one thing I want to point out, suppose you were asked what is the square root of x plus the square root of y. That is not necessarily equal to, that is not equal to the square root of x plus y, at least not most of the time. So, for example, is the square root of 4 plus the square root of 9 equal to the square root of 4 plus 9 is 2 plus 3 equal to the square root of 13? No, they are not the same. A second rule to memorize. How about the square root of x over y? The square root of x over y is the same thing as the square root of x divided by the square root of y. So if you saw square root of 4 over 9, that is the same thing as the square root of 4 divided by the square root of 9. That is 2 over 3. A third rule. The square root of x squared is the same thing as the square root of x squared. So in other words, it doesn't matter where you put the exponent, and both of those are equal to x. So the squaring and the square rooting cancel each other. And when you think about exponent rules, this makes sense. The square root of x when squared, well, the square root of x is simply x to the 1/2. So we're talking about x to the 1/2 squared. That's equal to, over here we have x squared, and we're taking the square root, so that is x squared to the 1/2. Both of those are equal to x to the 1. You multiply the exponents, that's the same as x to the 1, that's the same as x. Let's look at an example. The square root of 9 squared is equal to the square root of 9 squared. It's equal to 9. The square root of 9 is 3. 3 squared is equal to the square root of 9 squared is 81. 9 is equal to 9, so it all works out. Suppose I had square root of x cubed. That is the same thing as the square root of x cubed. X to the 1/2 cubed is equal to x cubed raised to the power of 1/2. Both of them are x raised to the power of 3 over 2. So the more general rule, the square root of x, x to the 1/2, raised to any exponent, let's call it n, is the same thing as x to the n raised to the 1/2. Both of them are x raised to the power of n over 2. Let's look at another rule. X raised to the power of, let's say, 1 over b is the b root of x. So we know that x to the 1/2 is the square root of x. We know x to the 1/3 is the cubed root of x. So the index number, as it's called, that goes inside that little divot there. X to the 1/2, that's an implied 2x squared. Suppose I wrote xy raised to the power of 1 over b. That is the b root of x times y. Next rule, suppose I had x raised to the power of a over b. That is the b root of x to the a. X to the 2/3, that is the cubed root of x squared. 8 to the 2/3 to the power of 2/3 is the same thing as the cubed root of 8 squared, which is what? The cubed root of 64, and the cubed root of 64 is 4. 4 times 4 times 4 is 64. Let me also point out that the cubed root of 8 squared is the same thing as the cubed root of 8 squared, same thing. And the cubed root of 8 is what? The cubed root of 8 is 2, so this is 2 squared. This is equal to 4, so it all works out. Last rule to memorize. Suppose x is positive and suppose x is negative. If x is positive, the square root of x squared is equal to x, right? So the square root of 2 squared, the square root of 4, is equal to 2. All well and good. But if x is a negative number, the square root of x squared, it's the absolute value of x. What does absolute value mean? You may recall it means a non-negative number. So for example, what's the square root of, if x is negative, suppose negative 2 squared. What's the square root of negative 2 squared? That is positive 2. We said earlier, if you have a number underneath the square root symbol, the result is the positive root. That's the same thing as the square root of positive 4, which is positive 2. So the square root of negative 2 squared, it's not negative 2, it's positive 2.